Okay, in the previous class we learned about descriptive statistics, wherein which we talked about mean, median, mode, and how do they appear. Then we talked about range, outliers, interquartile range, and variance. So today we'll be looking at skewness, we'll be looking at correlation, covariance, and we'll take it from here. So, so directly jumping to the skewness part. Now, skewness is nothing but what your distribution looks like basically. So, is it symmetric or is it move? Is the mean, median, and mode, or are they towards your right, or are they towards to the left? Okay, so basis on that, we calculate the skewness. Now, um, if your skewness is positive, okay, then you will see that the mean, median, mode are very close to the initial values in the distribution. And if it is negative, if the skewness is negative, then the mean, median, mode are towards the right, or they are in other words, for negative skewness, mean, median, mode are usually higher, okay, whereas for positive they are lower. So let's have a look at the sale price. So by looking at it, can you tell, is it left skewed or right skewed, or is it positive skew? Okay, it's written here positively skewed. So it's positively skewed because the mean as compared to the highest value, max value, it's very low. Okay, so mean would be low, median would be low, mode would be low. And in this histogram, always remember, higher the bar, okay, higher the highest bar will give you the mode value always. So if some interviewer shows you a plot of he shows you a histogram and tells you tell me what is the mode, okay, then this bar that you see, so this value, whatever the value is, that will give you the mode. Okay, if it was a normal distribution or symmetrical distribution, then mean, median, mode all will be on the highest point. So whatever the highest bar would be, that will give you the mean, median, mode, all three values. But for positively skewed or left skewed, left is positive, remember like that. Your left hand, I mean, you have to remember this way: left hand driving, which they do in US, right? So just take some real world scenario to remember this easily. So left means positive, right means negative. Okay, this you have to remember. So for left skew or positive skew, always mean will be greater than median, and that will be greater than mode. Okay, whereas for negative skew or the right skew, it is the other way: mean would be lesser than median, and that would be lesser than mode. Okay, any questions here? uh,
Can you please
sure, explain again.
once again tell me?
Sure, sure, I'll explain. So Swapnil, meanwhile,
Yes,
can you just check once with Rupali? She told me she would join the class. Okay,
Okay, sure.
yeah. So skewness, okay, basically understand what skewness is. Skewness is measuring what your, um, just give me one quick minute, please. Um, Rupali is, okay, sorry about that. Um, So skewness basically measures your asymmetry of your probability distribution, or the how much of symmetry exists, or how much of deviation exists from normal looking probability distribution. That's what skewness is measuring. And if it is left skewed, which means this bulge that you see here, bell shape that you see, if it's towards the left, okay, which is like this, here it is rising and then falling, correct? So if it is like this, then we call it as positive skew. Now for positive skew, always mode will be lesser than median, and median will be lesser than mean. And for symmetrical distribution, everything will be on the same line. That means mean will be equal to median, will be equal to mode. Now for right skew or negative skew, right is negative, left is positive. Okay. For right skew, median, mode would be lesser than median, that would be lesser than mean. Okay. So for example, if I do a dist plot or a hist plot, it doesn't matter, both are same. Dist plot is distribution plot, or hist plot is histogram. So both are one and the same. When you do this, you will get a plot something like this. Okay. And it is towards the left. Okay. If it was towards the middle, it would rise from here, it will come somewhere here, and then it will go like this. So that would have been a normal distribution, but here in this case it is on the left side. Clearly we can see that. So for that, if you calculate the skew, it is 1.88. So it is positive skew, it is left skew, and for this skew, just by looking at the value, you should say that the most of the values are concentrated on the left. Okay. And um, second. Okay. And likewise, if I have calculated, I have selected all the int values and float values, and to that I have tried to calculate the skewness. You can apply skewness as a function directly on your data, and when you do, you can get the skewness for most of the variables. So some are negatively skewed, that means the distribution is towards the right. Okay. And some are positively skewed, so I have plotted those one by one. So this is how you can do a histoplot. So I have taken this miss val, which is positive, or let me take a pool area also. Maybe that will give a better description, distribution. Okay. All right. So if you notice, all the values are concentrated on the left only. Okay. And they are not neither on the middle nor on the right. So left. That's why its skewness is very high. It is positive value. All the values are concentrated on the left. Likewise, I have taken another column wherein which you can do a histoplot, and you can see most of the values. There are little bit of concentration of values here, but if you notice, generally it is on the right side. All the values are concentrated on the right side, like this. Okay. So this is your right skew, also called as negative skew. Okay. um, and the value would be negative. Is this clear? Is this clear? Any doubts? Okay. So if there are no doubts, then we have Balmer rules for understanding this skewness. So if the skewness is less than -1 or greater than 1, if the skewness is either less than 1 or greater than 1, then we call it this data distribution is highly skewed. Um, don't know if I have her number. Okay, she's here. Okay, all right. So I was saying if the skewness is less than -1 or greater than 1, okay, then the data distribution is highly skewed. But if it is either between -1 and -1/2 or between +1/2 or +1, then we say it moderately skewed. And if it is between -half and 1/2, then it is almost symmetrical. Okay, so how you understand just by looking at these values is, for example, 0.033 full bath, right? This is very symmetrical. Why? Because it is lying between +half and -half. Either that means if it is either positively -0.5 or +0.5. So this is almost symmetrical. That we can check just by plotting it. What you can do is you can just do the same thing. Okay, so as you can see, most of the values are concentrated in the middle. Okay, here. So if you do a so although they are discrete values, okay, they are not continuous values. This we already saw, right, in some of the distributions. Um, and although because of the distributions, okay, here are the distributions. No, this is not the one. Anyway, I'll show you. So in this is can anyone tell me what type of distribution is this?
Negative. This is
Mm,
negative distribution.
okay,
Can you
so
hear me?
yeah, I
Positive.
can hear you. No, why is it negative? This is neither negative nor positive, no? Why? Because if the values are in the middle, most values are in the middle, then it is symmetrical. That means it is neither positive nor negatively skewed. Okay, so this resembles close to symmetrical
So
one.
most of the values are on the
Middle,
left side, na here.
yeah, most of the
Like
values, just remember this plot. So most of the values are in the middle. Okay, so it is symmetrical.
the positive skew, what we call it as is the left skewed, right?
Left skewed,
Positive
yeah,
is nothing but the left skewed, yeah.
yeah,
And negative is the right skewed.
correct.
So when the mean mode, they are okay,
Very close to the center. Okay,
center.
yeah.
Hmm.
So likewise here, if we calculate the mean and median of this, okay, and if I just do a mean median dot mean, okay, it's 1.566. Where is 1.5? Here, it is in the center. Mean is here. Okay, likewise if I do median, okay, that is at 2. Median is at 2. Mean is here, median is here only in the almost close to center. And mode, mode is also 2 only. Okay, here. So that's what, if all the three values lies towards the center, then it is symmetrical. If all the values lie on the left side, then it is left skewed or positively skewed. Okay, and if all the values lie towards the right, then it is right skewed or negatively skewed. Clear?
Yes. Yes,
Okay,
clear.
Yes,
Okay.
yes,
okay,
yes.
okay. So this is what we have indicated in the plot above. For a positively skewed distribution, mode would be less than median, that would be less than mean. And for the right or for the negatively skewed, okay, or the left skew, then mean would be less than, median would be less than mode. So these are all interview questions. Okay, some companies, I myself attended long back, attended a interview in the very first elimination round. So where they give all these questions, they confuse confusingly they ask, they show you distribution and say ask you some, give you some options or something like that. So you have to remember the differences. Okay. So if you want to understand skewness and kurtosis, I've opened the link. I've provided a link here. You can go through. For example, this is called as skewed. This is also skewed, but this is called as right skew. Okay, this is left skew, and we know left is positive. Left is positive, right is negative, and this is normal distribution. Okay, so for example, someone, they have given a very realistic value. Someone lifting the weights. That means different people coming and using these weights. It has created a distribution in such a way that most of the values are concentrated in the middle. That means, on average, all people are able to lift between 45 to, or the range that is 35 to 55 weights. Okay, and only extreme, some people are able to lift 100 plus, and very few again are able to lift 10 to 15, or maybe they are not lifting at all. So anyway, so that is what the measures, skewness measures how your mean, median, mode are distributed in a probability distribution. It could be any distribution. It could be binomial, Bernoulli. It could be other distributions, exponential, whatever it is. Okay. So a quick question. Okay. So here, as you can see, for right skewed, you will have long tail. Yeah. And this is another way of looking at it. Okay. One, we talked about positive, negative. Then we talked about direction, right, left. Okay. Now they are talking about tail. Okay, so this is assumed to be a tail. So when the tail is on the right side, it is called as right tail. This is important because we are going to do something called t test, tail test, one tail test. Okay, so that is also you have to remember. Long tail is on the right. Okay, sometimes the tail could be on the left also. Sometimes
One
tail could be
question
on
here.
both sides. Yeah.
Yeah, this is actually, if we compare the picture that is in our Jupyter notebook, can
Yeah.
we please have a look at the picture there?
Mm-hmm.
Yeah, just up. Yeah, here. Now here
Mm-hmm.
it is a left skew. We are calling it as a positive skew.
Mm-hmm.
Okay, can we go back to that picture again? Mode, median, mean.
Mm-hmm.
Mode, median, mean. So this is termed as left skewed in our this thing. Can you just have a look at that? Right skewed instead, it should be left skewed, I guess.
It is left skewed.
Uh,
Just have a,
it should be
है
left.
ना?
It is
Left.
Yeah,
leftly
it is a
skewed
left.
only. Maybe in the picture
Uh,
while depicting,
okay.
they
I
have put
just
it
got
wrong.
confused there. Yeah, I just got confused there. It is a left skewed, right?
Yeah, it
Okay.
is a
Please
left
go ahead.
skewed only. Okay. So while
Yeah,
I think what they should have written is, instead of writing right skewed long right tail, they should have written long
left.
right tail. That should have ended the
And
terminology.
or we can say it is a left skewed or it is positive skewed.
Positive.
Positive skew.
Mm.
Yeah.
Mhm.
Okay. So
But
don't get
again
confused.
in the below, again in the below discussion, yeah, just
Yeah, they
below
have
that,
confused it.
just little.
Yeah, yeah.
Yeah. In the above picture, can we go in the above picture?
Mm-hmm.
Yeah. Here, just beside below the line, they are saying in the distribution with negative skewness, it should be positive skewness, left skewed, right?
Left skew is positive, yes.
Positive, yes. It has to be positive skewness, left skewed.
Okay.
So in the picture as well as
Maybe I have a
Yeah.
confusion here
Mm-hmm.
because maybe the left skewed, the data skewness is like a tail part. Is it like that? Maybe.
No, even if it
Uh,
is tail, the terminology still should not change. Okay.
uh,
Here, I think they are referring to, when they say right skewed, maybe they are talking about the tail. Okay, that's what Rupal is pointing out. But anyway, as per the book, you don't worry about this. As per the book, statistic book written by well-known authors, I have verified. So this is a right interpretation.
the-
Okay. Okay.
So we will be opting for this only.
Yeah, yeah,
I mean,
we'll
we'll
go
stick
with
to
this
this
one only.
interpretation.
Yeah, yeah, this is the right interpretation. Okay. So maybe I'll give you a different reference. Don't worry about it. Okay. Anyway, so is this clear about the skewness?
Yes.
Yes. Yes.
Okay. All right. The next thing is, um, we want to again we are trying to visualize how the mean median mode looks like for a left skewed data or a positive skewed data. Okay. And again, see, this is the right interpretation, I can tell you. Okay. Just by looking at the values, just by looking at the skewness calculated values. I think data camp got it wrong. um, so when you plot this is on the left side, but for the same thing, if you calculate, see, it is a positive skew. So left is positive, okay, and right is negative. Right is negative because we have evaluated that also. So this is right. Here remod add is on the right, but that has uh, negative value somewhere here.
Negative.
Okay, here or somewhere about here it is negative. So we our interpretation is correct, so don't get confused into this. Okay. Okay, next thing is we are visualizing mean median mode. Mode will always be on the left side, median would be in the middle, and mean would be on the right side, which means right side in the sense it will be smaller than median. Median would be smaller than mode. That's what we are saying here. Okay. Next thing is we want to understand what is variance. Okay. Variance is nothing but the spread of the data, how well your data is distributed for various values. Okay, that is what variance talks about. Now, if you want to understand variance mathematically, again, just giving you a clue, variance is nothing but
Just
dispersion of
sorry to
data.
disturb you.
Yeah,
Can you increase the font size a bit?
sure,
I'm sorry.
sure, no worries. Is this better?
Yeah, yeah.
Okay. So variance is nothing but the measure of dispersion, how well your data is spread, okay, across various values. And when we talk about variance, we have to talk about population and sample as two separate things. Okay. The reason being, population nobody can measure. The data that you get for analysis or whatever the data collection is done, that is always going to be a sample data. Okay. Now, it is literally impossible to get the data of all the 8 billion people. Okay. And get the data from various um, I mean equal uh, data from all the socio-economic backgrounds. So that is not possible. When you measure the variance of that, it will more or less depict a certain distribution. Again, this could be any distribution basically, okay, basis on what you are trying to measure. But because we don't have population, we always rely on sample. Sample means we select a piece of this population, small sample, small size of this variance, wherein which it will describe the same attributes that a population exhibits. Okay. For example, we measure the mean, we measure the variance, okay, how the spread of data is, we measure mode, and all other values. So we always work on sample. Okay, this was again a trick question asked um, in one of the interviews. Okay, so how would you collect the population data? Is a very simple question, but you can't collect. That is literally next to impossible. Okay, so you can only collect sample, and for sample data you can do all your measurements. Anyway, to calculate the variance, you have to, if you look at the data, um, so in all these formulas, don't worry about grouped and ungrouped, so that's not our concern, but any formula that you pick here. So if you can notice, xi is your data point that you're trying to measure, x bar is the mean. Essentially, in variance also, just like your standard deviation, again, standard deviation is the square root of variance. Okay, so that means if someone asks you what does the variance measure, tell me what does variance measure. So this is the interview question I myself asked multiple times. What does ANOVA measure? That is my interview question, one of the interview questions, where where most people don't first of all, most people don't understand what the question is. Okay, so ANOVA is just a another test. Again, we'll look all of those into details. But when someone asks you what does all these tests or what these variance measures, basically the formula has the answer to that. So if you notice xi is a data point and you are subtracting it from the mean, that means you are calculating the difference of your point be from the mean, or you're taking the absolute value or whatever you're doing. Here you're taking the summation, but the point is you're actually measuring how far away your point is from the mean. Okay, so that is what variance measures. That is what exactly standard deviation also measures. Why? Because standard deviation is the square root of variance. So what variance measures is also measured by standard deviation. Essentially, if someone asks you what does the variance measure, variance measures how far away your data point is from the mean in the distribution. Okay, so
So,
hmm,
uh, is it same as that of RMSC,
root
root
mean
of the mean
squared.
error? Yeah.
Hmm.
So we are actually squaring the absolute error here. We are taking the mean of that,
Yes,
and
yes,
when we actually get the STD, that is
yes,
standard
yes,
deviation,
yeah,
we are taking. So it is RMSC, root of the mean of
yeah,
the square of the error.
yes, yes.
Yeah.
Even RMSC measures the same thing. Okay,
Yes. Yes.
so RMSC there the interpretation is little different. Okay, here interpretation is different. Here
Okay.
there you have okay, I'll explain. So here it is just measuring, you are calculating, you are basically taking a frequency of values, you are taking some certain values. Okay, so like this, for this you are calculating the mean and whatever your point is, so each point you are subtracting from the mean. Okay, and you are getting the variance. And if you take the square root of 23.5, you will get the standard deviation. That is the interpretation. The point is
Yes.
all these values are random values. Okay, some random values taken for which we have calculated variance. There for RMSE, what exactly RMSE is measuring is, in a distribution you are drawing a best fit line. From the best fit line, how far away is your point? That is what you are measuring there. On
Okay.
average,
Okay.
how far away your point is from the best fit line is what RMSE measures. Okay, but here
So we
variance
are basically
measures.
doing the
Hmm,
okay. Yeah. So it's we are calculating in the regression, and this is specifically for the sample data or
yeah,
the population data that we are
yeah,
calculating. But
yeah.
the
That's the
formula remains same, but the concepts are actually different. Got it.
yeah,
Thanks.
yeah. But nevertheless, both the things are measuring the same thing. How far away your point is from the mean. Okay. So there also
Yeah.
in RMSE, on an average, how far away your point is from the line,
Yeah.
best fit line. Okay, that is what it is.
Yes.
Okay, so for us, for variance, we don't have to worry about the formula. We can simply use the variance formula, and you can see the variance is for this sales price is so much. Okay, and if you take the square root of it, so the standard deviation is 79.442. That means if you also calculate the mean, yeah, if you calculate the sales price mean, okay, so let me calculate the mean as well. Okay,
And what is the sale price?
sales price is the target, is the price of the sale of the house.
Okay, this one.
Yeah, yeah. Okay, it is 1,80,921 actually. So on an average, the house is selling for 1,80,921, and the standard deviation is 79,442. That means on an average, if you take any point randomly, okay, it could be any point. On an average, if you take randomly, that point will show that it is on an average, again average on a mean. Again, if you calculate for individual points, it could be different, okay, but on an average, it is roughly $80,000. There is a difference. That means the interpretation is, whoever is going to buy or sell the house, going to buy the house, is either paying $80,000 extra, or they're underpaying $80,000. That is, okay. If this is the mean, central line is the mean, this is very important. Again, for a normal distribution, how you, if the data is normally distributed, and we can say, again, you don't need the proof for this, this is just how it is. For normal distribution, what you see on the x-axis are the standard deviations. That means this is one standard deviation, this is two standard deviation, this is three standard deviation, okay. This is minus one standard deviation on the left side, minus two standard deviation, this is minus three standard deviation. That means if I say, if my standard deviation is $80,000, okay, if the mean would be 1,80,000, that means this center point is 1,80,000, okay, and the difference between this point and this point is $80,000, which is your STD. So that means on an average, if a customer is buying the house by paying extra 79,442, that means he will fall in this bracket, in this line, in this box, whatever this box is, plus one standard deviation. If he is paying less than $80,000 less, he is paying, that means he will be under this section, minus one standard deviation. Or in other words, 68.3% of the users who fall into this bracket are either paying $80,000 more or paying $80,000 less while buying the property, okay. And likewise, the difference between one standard deviation and second standard deviation is this difference is again $80,000. Or if you want to say, 95.4% of the users who fall into plus standard deviation to minus 2 standard deviation, plus 2 to minus 2 range of standard deviation, which are 95.4%, are buying the house, okay, with approximately 1,60,000. Either they are paying more or they are paying less, 1,60,000 dollars while purchasing the property. So all those users fall under this bucket, okay, 95.4%. And the rest 5% are 2.5% distributed here, 2.5 distributed here, okay. Or in other words, 99.7% of users, okay, who fall under this entire plus 3 and minus 3 bucket, are buying the houses with within 3 standard deviation, that is 3 times this value range, okay. Either they are paying less or they're paying more, okay. So there was another interview question, I just remembered, that this plot was given, and these values, although these percentages were not given, but this plot was given and asked, and this only this left side area was shaded, okay, only this. Then that was pointed as A, okay, something I will draw and show you. But okay, this particular area, what is the percentage of users who will fall under this category, is what the question was. The answer is 2.5, roughly 2.5. um, okay, so if this is your bell curve, okay, and what we are saying is, this is your mean, this is one standard deviation, two standard deviation, or if you are saying three standard deviation, somewhere here, okay, just for the sake of understanding. 3 standard deviation. If someone highlights this plot somewhere here, something like this entire plot was okay. So this area is shaded. Now the question is, what percentage of users fall onto this bucket? Okay, the answer is you should
So
know.
it will be 99.7 minus 95.4 by 2,
Correct,
when to
correct.
be exact.
Yeah, to be exact.
And does that represent uh, the purchasers who are paying the least
Yeah,
cost or the
yeah,
least price for this?
yeah.
Because these are the people who are buying it at the least price.
Yes,
Whereas
absolutely.
if we consider the one sigma at the right extreme,
Yeah,
then those are the people who are basically purchasing at the highest of the cost, highest
yes,
of the price, rather, I would
absolutely,
say. Right?
absolutely. Yes,
Yeah.
yes. Yeah, absolutely. So, so this is your 3 sigma. So these people are paying the highest. Okay, and these people on towards the left are paying the least. And the way how you calculate this is like Sachin said. So if this is your 95.4, okay, and from here to here it is 99.7. So you subtract 99.7 minus, again this you have to remember top of your mind. They won't give you these percentages also. Okay, so for a normal distributed plot, this is what the data would be. 99.7% of the data would be within 3 standard deviation range, that is plus 3 to minus 3, and 95.4 would be within plus 2 plus 2 to minus 2 range, and only 68.3 would be in the plus 1 to minus 1. So if someone points out what is this percentage, then you have to subtract roughly, or you can remember like this also. If you don't remember these exact values, you can remember like 99, right? 99 point roughly 5%, or roughly 2.5%. You can calculate exactly what it is, what that value is, if you like. So if it is 99.7 minus 95.4, okay, so that is roughly 2.14% or 2.15% of people fall into this grade, this area. Okay, this section would
Uh,
be.
I have a question
Yeah,
here.
yeah,
Uh, so now this is for the normal distribution, or we call it as a standard distribution, the
yeah,
bell-shaped curve normally that we get there.
yeah,
But not always our data is going to be in the
yeah.
normal distributed form.
Correct.
It can be left skewed or it can be right skewed.
Yeah,
So in those cases, in those cases, this will be different, right? I
this
mean,
would be
we'll have
definitely
to make it.
different. Okay,
Mhm.
and so we don't take such data. We have to transform that data into normal distribution. That we will see in data analysis how to do. That is also one of
That
the
is the
steps.
normalization.
Yeah,
Normalization.
normalization, standardization. Yeah. So using
Okay,
those
okay.
techniques, okay. Again, there are many ways basis on the type of distribution we have seen, right? For Bernoulli
Mhm.
distribution, there would be one transformation. For a left skewed data or positive skewed data, there would be certain type of transformation. For example, log transformation, or exponential transformation, or box Cox transformation. Okay, so some sort of transformation we have to do basis on, we have to judge basis on the distribution of the data. Okay, and that is where we are making going to make use of all these calculations: variance, mean, skewness. Okay, so all these calculations will make use of, will understand what the plot looks like, or the distribution looks like. Basis on that we will make a call. Okay, or you can automate that function also. So anyway, I will show you that in data analysis, because this is statistics, we are still understanding statistics part. Okay, so this is what it looked like for normal distribution. Again, moving on, for a again this is different to variance. This is not variance. Correlation means relationship between data points and the target variable. How effectively does your variable have relationship between itself and with the target variable? That's what correlation measures. Now correlation means correlation. See, if you just split the name, okay. So for correlation, if we say the correlation is positive and we say that the correlation is 1, what it means is, if the correlation is 1, what it means is, for every increase in, if for every increase of 1 in that correlated value, the the other value that we are measuring the correlation for would increase by 1, factor of 1. That means you're driving a car, okay, and you're driving a manual car, and for your car there are gear system, they have their own gear ratios. That means if you switch from one gear to another gear, that means first gear to second gear, by certain ratio your speed will increase only by certain range, okay, automatically. Again, you can try to push it, but it will get pushed only to certain limit, okay. So what we are essentially changing is, the change in one gear to another gear is positively correlated with your speed of the vehicle, okay. In that case, maybe the factor could be 5, correlation value could be 5, because if you change the gear from, again I'm just giving example, it could be 20 also, because if you change from first gear to second gear, automatically your speed could increase by 20 value, okay. So in that case we say the correlation is 20. Again, from you change switch from second gear to third gear, again the speed could increase by another 20. So you say the correlation is again 20. From third gear to fourth gear, again that repeats till fifth gear, you reach 100 speed, okay. So just like that, I mean, just imagine that scenario. So positive correlation means for every increase in one variable, the another variable would increase by that exact factor, okay. Okay, if the positive correlation here was only 0.5, okay, here if the correlation was only 0.5, okay, then what we mean is, if that increases by 0.5, this will increase by 0.5 only. That's what we mean, okay. Whatever the factor is, if it increases by that value, the other variable will also increase by the same factor, okay. In that scenario we call it positive correlation, okay. And positive correlation will always look like this climbing arrow. From origin, if you measure in this direction, if it goes, it is positive correlation. If it comes down from top to bottom, so it is negative correlation. These are very important, we are going to reuse them when we calculate pair plots and other different types of calculations, okay. And this is no correlation. Just by looking at the scatter plot, this is a scatter plot, by the way. Scatter plot always prints the dotted representation of the values. So here, if you see the spread of the values are such that it is randomly spread, there is no particular direction, hence the correlation is 0, okay. So correlation is necessary, essentially a measure of relationship between one variable to another, and this is very very important when we do a feature selection, okay. There we are going to reuse this concept.
Okay, can I ask something here?
Yeah.
So basically, here on the x-axis, we are plotting one variable,
Mm-hmm.
and say, for example, the gear ratio or
Mm-hmm.
the gear on which we are going, and on
Yeah.
the y-axis, we are considering the target variable,
Yeah.
and basically, we are plotting the slope. Can we say like that? So slope of this,
Yeah. Yeah.
if it is a positive slope, it
Yes.
is a
Yes.
positive correlation, and the slope itself is giving us the correlation coefficient. Do we say that?
Yes, you
The
can. You
slope
can.
itself is, I mean, if we consider the mathematically here,
Yes. Yes.
and it's a zero slope for no correlation and the negative slope for the negative correlation. Okay.
Yes. Yes. You can say that one also, because at any given point, if you want to measure, okay, so slope is this value, okay. So always your slope value would be positive for this type of
Yeah.
graph.
Change in the value of y for the change in the value of
value of
x.
x. Yes.
Okay.
So mathematically, what you said, we'll measure the angle here. Okay, if this angle turns out to be in such a way that this is in this direction, particular
Tan,
direction.
yeah, tan of the angle, tangent of the angle there
Yes,
to
yes,
be
yeah, yeah,
tan
yes,
theta. Yeah.
yeah. So if you see slope like this, then it would be positive. Okay, and this would be negative. Again, we'll talk about this in the regression analysis that we do. Okay, but here for now, just understand, remember that correlation will be positive for this type of line and negative for this type of line.
So,
Mhm.
so if my correlation is positive, means I am going to choose those features who has a positive correlation for
We
the.
are going to choose features that are highly correlated, both positive and negatively.
Negative, yes.
Okay,
Okay.
in both the
Mm-hmm.
cases we will choose. We will discard
Yeah.
the features that are non-correlated.
No correlation.
Yeah,
Mm-hmm.
Okay, because negative correlated, so increase in x value,
will decrease the
it
other
will
one.
be decrease the other one. So that
Yeah,
is why it is okay. Okay, yeah, got it. For
something
features
like
next one. Yes.
weather and temperature, right? So if it rains, the temperature will decrease. That means the amount of rain will determine the temperature. Okay, so if you plot temperature towards rainfall, it will look like this. Okay, higher the rainfall, decrease in the temperature. That's what it means. Something like that. Yeah.
Yeah,
Okay.
yeah. Right.
Yes.
Okay. Now, what we want to see is we want to understand what the correlation looks like for one variable to the target variable. Here we are just considering one variable, ground living area. How does that impact with the sales price? So you have a direct function called correlation coefficient if you want to calculate it for one variable. If you want to calculate for any two variables, that is one variable you are calculating with the other one, then you can make use of this correlate core coefficient directly from the stats model. Okay, import stats model from stats model. You can, okay, not stats model, numpy only. Okay, sorry. So in numpy you have a direct function, so you can make use of this. And if again I have multiplied it with 100 to, and here you can see 70.86. Now what does this mean? What it means is 70.86 percentage of the time we see that higher the living area, higher the sale price. Okay, that's what it means. For 70% of the time in the data we see that living area, living room area increase, also increases sales price. Okay, here I have taken multiple values to understand and calculate the correlation. For correlation, pandas gives us, this is a pandas function, this is a numpy function. Numpy you can use correlation coefficient and pass the values, or if it is already, if your data is in the form of data frame or a matrix, data frame is essentially a matrix. Okay, then you can directly apply the core function, and here you get this table. This is again very important. So ground living area with the lot area. So lot area is increasing with the ground living area 26% of the time. Okay. Garage area is increasing with ground living area 46 or 47% of the time. Okay. And it is sale price increasing because of ground living area 70% of the time. Okay. Hence it is positively correlated. I have plotted a heat map for that correlation, and from here you
Can
can
I?
see.
Okay, let us first hear your explanation.
Okay, so here you can see that ground living area. Okay, with the sales price is here, is showing as red value is here 0. 0.7. Okay, so again this is one of the questions asked, what is the range of correlation used in data analysis? Okay, quick answer is -1 to 1. Okay, so it could be negative correlated, it could be positive correlated. It goes from -1 range to +1 range. Okay, so in this case you can see ground living area is positively correlated, 70% of the time value is shown. Likewise, garage area, how is garage area increasing? With sale price. So if your house had one garage, or more garages, that would that would increase the sale price 62% of the time. Okay, that means if the house had good living area, good garage area, good lot area basically, so that would increase the sale price. That is what we are understanding here. Okay.
So,
Yeah.
yeah, I have a question here.
Hmm.
Now, if we say, let us consider cell number 75,
Okay.
where we have cell number, yeah, 75.
Hmm.
We are calculating correlation coefficient.
Hmm.
So we are getting the value, the answer is 70.86.
Yeah.
Does this, so do we infer from here,
Hmm.
uh, Archana, can you please put on the uh, mute? Yeah, thanks. So let us say if we increase the correlation between the sell price and the living room is 70.
Hmm.
So here what is X and what is Y here? So do we mean to say if we increase the living room area by 1 unit or
Hmm.
by 100 units,
Hmm.
the sell price will increase by 70 units or vice versa? I mean, increasing the sell price by 100 units will increase the living room area by 70 units. Uh, or
Yeah.
the same. So what is the dependent and what is the independent? So what is influencing what? That I want to understand basically. That when we say it is 70.86, so I just want to understand that is it the sell price influencing 70% the living room area, or is it the living room area influencing the sell price when we are trying to find out the correlation between these two? I just want to understand what is X and what
Both
is Y.
actually.
So, so
Both. The answer is both. So when you calculate a correlation, what you are essentially calculating is the interdependent. How much of this will impact sale price, and how much of sale price, the other way is also true, how much of this will impact this.
mhm.
Okay, it's the other way also. So how
So in
much
the
of
heat
ground
map,
living
we are
area.
getting the same numbers because of which we are getting the same numbers in the
Yep.
heat map also. Like
Yes.
lot area and sale price is
Yeah.
0.26
Yeah.
and lot area to sale price and lot area to sale price. Okay, so the interdependence of both these variable features or maybe variable on each other is 26%.
Yes.
That is,
Yes. So
and
yeah.
okay,
So
okay,
that is what it
right.
is. So correlation means means both, right? So
Both.
correlation means interdependent relationship. Basically, you can twist this and ask the same question. Okay, if I am to pay this much price, how much ground living area can I expect? That question also you can frame, or you can frame the other way. If I have ground living area of 100,000 square feet, how much sale price can I expect? Okay, both
Mhm.
way you can
Or
expect.
if we increase the ground living area by
Mhm.
100 units,
Mhm.
what do we expect the increase in the sale price? Or the
Yes.
other way around, if we increase the sale price by 100 units,
Yeah.
what is the expected increase in the ground living area?
Yes.
I mean,
Yes.
okay.
Both.
So it will
Both.
be 71.
Yeah. Both can be expected. Okay. So if you
Okay.
plot a line here, if you can see, it is increasing. Okay. This way, in
Mhm.
this direction,
Yeah.
it is increasing. So in that case, it is positively correlated. Okay. If it climbs from down to go up, it is positively correlated. If it comes down like this, it is negatively correlated. So that much you understand for now. Again, we are going to talk about all of these in detail in data analysis, but for statistics, this is more than enough. Okay. The next important thing concept is, again, very highly used interview question. How I mean, they twist the concepts in such a way that candidate fails to understand the question itself. So correlation does not imply causation. What we are essentially doing is calculating the relationship between two variables, but that does not necessarily mean it happens all the time. Okay, so this data set that we are studying is Boston data set. That may not be the case for Bangalore data set. Okay, not necessarily ground area will determine the increase in sale price for Bengaluru data set. It could be something else also. So correlation simply will not imply causation. It will not happen. For example, good example is given here. In a survey, they found that yellow colored cars and silver colored cars have least amount of accidents. Okay, and that is reality also. That is how the data set is. Just because yellow colored cars have lower cases of accidents, does that mean yellow color is the safest color? Yellow color is giving the safety to the car? No, right?
No way.
No,
No ways.
no, because maybe the people who prefer yellow color, there could be some link between yellow color and their personality itself. Only a specific personality type may be picking the yellow color, and maybe that specific personality type could be, maybe they are responsible drivers. Maybe that could be the reason. Or maybe yellow colored cars, okay, because this is yellow colors are shiny in nature or silver colors are shiny in nature, maybe they are reflecting the more sunlight, which means the person who is coming opposite to the that colored car, maybe he is able to see the car, identify the car very well. Maybe that could be another reason. But yellow color itself is not giving the safety. It is not adding any safety features in your car. Okay, so that is why we say, just because yellow color uh, in the data is or negatively correlated with accidents. Higher the yellow colored car, lower is the rate of accidents. Just because it is negatively correlated does not mean it is the reality. It does not show the cause and effect. Okay, something like that. Okay, this is very important. The reason why I say this is, sometimes the interviewer might ask a question something like, okay, I was wearing a red colored t-shirt and it rained, like that for 20 out of 30 days in the month. Now he will not specify which month, whether it was he will not specify which season also, whether it was rainy season or summer season. Summer season impossible, rainy season maybe he is talking about, but he will not give you that information. So he'll say, okay, does that mean my red color determines the um, rain value? So does that mean if people ask me to get it rained, should people ask me to get it rained by wearing red t-shirt? So do I have some powers like that? So something like that. So correlation simply does not mean causation. Okay, so as a candidate you have to be smart enough to ask the questions, implying what season, what day, and all of those. The interviewer will understand that you know your fundamentals correctly. Okay, so up until this point we talked about single variable affecting the sale price. Now covariance, we talked about the spread of the spread of the data for one single variable or one single feature. Covariance, that means you're taking into account multiple features and you're trying to calculate how well your features are showing the spread of the data. Okay, here correlation, you're calculating the relationship between the variables. Here for covariance you are calculating how well they show the effectiveness of spreading. So covariance is nothing but, again this is also measuring the relationship. Okay, but again if you notice, variance relationship is being measured. For variance we saw no how far away the point is from the mean, that you have to remember. Here you're doing the same thing but for both the variables simultaneously. That is the difference. Variance and covariance. In covariance you consider two, you try to calculate the spread of the data for two variables, whereas in variance you calculate the spread of the data for single variable. Okay, so that is the difference. Now for covariance, you can simply apply dot cov function which is offered by pandas. Now if you calculate the covariance, you can see some values have positive. Okay, and okay, although there are no negative values here, but some have increased by little bit and some have increased by high values, like 8 e to the power of 8 is 10 to the power of, that means there are 8 zeros after this value, so it's a big value. Anyway, so from this what we can interpret is, if two variables move in the same direction, it results in positive covariance, and if two variables move in opposite directions, it results in negative covariance. So we have not calculated negative covariance here, but what we can do is data dot select underscore d types of, I will say, uh, or let me pass the value. I'll select all the int values and also select float values. If I select all these values, and let me check if I, okay, I got those values. Now if I apply dot curve, now you can see some values have negative correlation. Okay, so there is a feature called ms subclass, and that has a negative covariance. Here we are calculating covariance. Correlation also you can calculate the same way. um, order. Okay, so this is correlation. This indicates essentially how your variables have impact on one another. So if they one increases, the other should increase. But here in covariance we are saying, we are talking about the spread of the data, essentially comparing. Here also the calculation, underlying calculation is, we are measuring the variance of both the features. Here what we are saying is, this if lot area with ms subclass, so it's showing the difference in the data points, spread of the data points is 59,000. Okay, it could be square. Again it is unitless, because this has a different unit, this has a different unit. You can't apply unit to this, but you can simply say, by 59,000 points, lot area, the variance of lot area is differing from ms subclass. That means if I plot lot area here, um, data dot lot area, okay, dot plot of kind is equal to scatter. So if I do a plot, okay, okay, I will type hist for one. Okay, so if I do a hist, so this is what it is. But if I want, okay, let me do a scatter only, but for two I will do data or scatter plot of data dot lot area, comma, data dot data dot ms. Okay, okay, anyway, uh, let me do this one only. Okay, so this is lot area. Okay, so lot area, the point what we are trying to understand from covariance is the spread of the data. So what essentially we mean when lot area differs by 59,000 points with ms subclass is, if this is your lot area, and if this is your ms class, okay, so notice the x range, it is till 175 only, and notice the x range, it goes all the way up. But if you do a comparison of these data points, the spread of the data, if you do a calculation of mean, median, mode, and all of those, and try to calculate how far away the points are, there is a difference of minus 59,000 points between this data set, this distribution, as well as the above distribution. That's what we mean. So if we calculate the mean for this, somewhere it may come, because this is left skewed. Okay, the mean could be shifted on the left side only. Okay, so mean could be somewhere 25 to 75 range. And here, if the mean this is also left skewed, the mean could be somewhere here. If this is 25,000, this could be somewhere around 10,000 something. So if we do all these comparison point to point of all these data points in this two sets, there is a difference of 59,000. That's what it means. Okay, is this understandable? We're just comparing the variance here. That's the difference,
They
not the.
they are in the but the spread is in the opposite direction. No? That's what. Can we just have a little? Can we just go a little up there?
Yeah,
Uh, where the explanation is given. There are three lines of
sure.
explanation for covariance.
Yeah,
So yeah, here it so, so when following are the interpreted values. When two variables move in the same direction, it result in the
positive
positive covariance.
covariance.
And if the two variables are moving in the opposite direction, then that results in the negative covariance.
Yes.
Now here we consider two variables
hmm
which are having like minus 59,000. So they are moving in the opposite
Opposite
direction
direction.
necessarily. We
Yeah.
mean. That means if one has got a spread in one particular direction,
hmm
say towards right, or we can say, and so necessarily the other will have its spread in the opposite direction, right?
Yes. Okay. So that, yeah.
Because of this negative thing. And if it is positive,
hmm
so if one is spreading in plus direction, so the other winner will also spread in the same direction, right? That what does that?
Yes, I can answer that question using xlim. Okay. So
Okay.
if I limit plt dot x limit of, let's just say I want to limit the values of left and right by certain value x lim of, let's just say 10,000. Okay, 0 to 10,000. Now see, 10,000, no, 25,000, because most of my data is concentrated here, right? On the left, although it looks like, when you compare with outliers, it looks like it is on the left side. But if I actually limit my majority of the data till 20,000. Okay, let me limit 20,000. Okay, now see, so essentially I can take this entire data, fit it here in 175 range. Then if you compare, this data is on the left side, this data is on the right side. Majority, this entire data, if I try to fit this data here within this. Okay, um, and maybe give a different color, I don't know if this will work, but yeah. So notice now both are on the same plot, and to this I will apply, let's just say 12,000. Now see, you notice the difference, right? So this entire data is on the left. Okay, and this data is, in comparison to this, is on the right side. So they are in
That
opposite
is
directions.
that is why they are in there is a negative covariance.
Yeah, negative covariance of 59,000, and that 59,000 is also because of outliers in this data. If you subtract that outliers, that value will decrease further, because most of the concentration of this data is around around this 6,000 to 12,000 or whatever. So this range only. Okay. Anyway.
And what would be the case for the positive covariance then? Like
Oh,
these two
mhm.
histograms, One
Yeah,
is the red color histogram and the other is the blue color histograms, and they
yeah.
are
Ground
spread
living
like this.
area and
If we consider how will it look like, can we just have
yeah,
a look at
sure,
that?
sure. Ground living area and lot frontage area. Okay, here I have added 12,000. Let me decrease it to 3,000. Okay, here also it more or less looks like that only, but again, it's more like what is the upper limit. Okay, if I put a hash to this, it's mostly on the upper limit of the data. So here, okay, maybe this is not the right or similar representation to explain this concept. Okay, let me do one thing. Okay, I will get a better representation of
Yes,
it,
yes,
because
yes, yes. That is
here it is
yeah.
little confusing.
Yeah, we are not able to make out like
Make out
why
the
this
difference.
negative. Yes, yes. I
Yeah.
mean that. No worries, no worries. Yeah, yeah.
Okay,
Sure, sure.
all right, no worries. So
Thanks,
we
thanks.
will look that in
We'll,
the next class. Okay,
we'll
it's
park it.
already
Yeah, yeah.
9:45. Okay, breakfast break you can take, and then we will you can rejoin at 10:15, and we will see inferential statistics today. Okay, most of
Okay.
it
Yeah.
would be a repeated one. Okay, inferential is more to do on the um, probability side, but very important concepts. So just come back at 10:15. We will see that. Okay.
So I have one quick
Yeah.
question.
Yeah.
Like, if the data is strongly correlated,
Mm-hmm.
so we consider the strongly correlated data more while feature selection, or it's like they are loosely correlated, or like how we make sure that which features to select. So is it important component for the feature selection correlation?
Yes. Yes. Correlation. There are many methods. Honestly speaking, multiple ways to judge how much of impact a feature has on the target variable. Correlation is just one of them, and the two
Okay.
again we'll see in data analysis. There are different types of correlation also. Pearson, Spearman, Kendall. Okay, different types of correlation and different types of feature selection methods. Okay, like RFE method, recursive feature elimination, and multiple ways are there to select feature selection. We will see all those in um data analysis class. For now, for the sake of statistics, this is more than sufficient. That what
Okay.
correlation is basically telling is what we need to understand. Yeah. Okay, I will stop the class here.